Dynamics of system of particles. Let's consider we have many particles in space. For example, we have total number of n particles, where we can some particles denote as mj and me and so on. And these particles are acting together, are interacting in internal meaning between each other, and also this system of particles is interacting with outside environment. So let's explain this situation on this more specific picture. So we selected some particle with mass mi. So mi is a mass of ith particle, and mj is a mass of jth particle. And these particles are in different places, so we can point to first particle by displacement vector rj, and we can point to this particle by displacement vector ri. So there is a r, either j or I, it's a displacement vector. And as I have already said, these particles are interacting between each other. So we can find, for example, there is a force Fij, and this is a force from particle mi to particle mj. And because there is a law of action and reaction, there must be a force which has same size but opposite direction and is denoted Fji. It's a force from particle j to particle I. The system of this denomination Fij is an internal force, and the system of this denomination is from ith particle to jth particle, and opposite. Fji is a force from j to I particle. Beside this system of particles is interacting with external space. So there can act some external force to this particle. For example, there is Fe as external to ith particle. So Fie is an external force from such external to particle I, acting to particle I. we will use these relations in further calculation. So we can denote that sum of all external forces acting to particles over all particles is Fe. So this is a sum of all external forces acting to system of particles. And similarly, we can denote that displacement vector Ri by external force Fi and sum of this over all particles is a resulting moment of external forces acting to system of particles. So we can say that this is ME. So it's a resulting moment of external forces, and this is resulting external force. So if we have many external forces, we can sum them, and this result, this sum, we denote as a resulting external force. And similarly, the moment of all external forces, and sum of moments of external forces is equal to resulting moment of external forces. For internal forces, we can write that sum, or better, maybe I can first denote this, that Fji is equal minus Fij. It's what I have been talking before. So if we have some internal forces between particle itself, so they are in compliance with law of action and reaction. So this is a force of some size, and this is a force of the same size but with opposite direction. So if we sum them, so result is equal 0. So we can write that sum of all forces Fji over j and cross sum over I is equal 0. So we can say that resulting force of internal forces is equal 0. And similarly, if we make a moment of these internal forces over all particles, it is equal 0 too. So it's logical, because if resulting force of internal forces is equal 0, so the moment of a resulting moment of internal forces is equal 0 too. So this is a resulting moment of internal forces. So is equal 0, 0. If there are some forces acting on particles, so we might expect the motion of particles. So we can expect that particle m has an acceleration ai. So we can write an equation of motion for ith particle. So once again, we can write equation of motion for each particle. So mi by ai is equal sum of external forces acting to ith particle plus sum of internal forces acting to particle I from J to I. Okay, so this is our outcome of this talk. And when we expect that J is from 1 to n, okay? So now let's talk about law of motion of center of mass of system of particle. What is a center of mass of the system of particles? So if we have many particles in the system, so for example we have ith particles, so there is mi, and this position is denoted by displacement vector ri, so ri has coordinates xi, yi, and zi. So this is a displacement vector, as we already said. Displacement vector of ith particle. And we can calculate a center of mass of this system of particles. So somewhere there can be a point, not a particle. Be careful about this. It's only a geometric point, C, with displacement vector RC. What is RC? With coordinates xc, yc, zc. So this is displacement vector of center of mass. So it's only geometric point. It's not a position of any particle. It's just a center of mass of this group of points. And we will discuss the law of motion of this geometric point of the center of mass of particles. Okay, so we know, I hope we know, that if we want to calculate a center of mass of particles, we calculate it like this. So m by rc is equal sum of this multiplication mi ri over all particles, where m is a total mass of system of particles, so it's sum of all masses, so it's a total mass of system of particles. This. So from this equation we can calculate the position of center of mass. But we can also make a derivative of this equation. And if we make a derivative of the left side of equation, we get m, it's a constant, it's standing outside of the derivative. So there is a Vc, and this is equal sum of mi by Vi, where Vc is a velocity of center of mass, because Vc by definition is derivative of Rc over dt. If we make another derivative, we get m by ac is equal sum of mi ai over all system. So a c is an acceleration of center of mass, because acceleration is dvc over dt by definition. Acceleration is a derivative of velocity with respect to time. If we put this equation together with previously got equation, what was equation of motion of ith particle of the system. So it was mi by ai is equal total external force acting to particle I plus total internal force acting to particle I from J. And if we sum this system of equation from I is equal 1 to n, so if we make a sum of this equation, because it's ith equation, and for first particle we have first equation m1 by a1 is equal fe1 and so on. For second particle we have an equation m2 by a2 is equal f2 external and so on. And for nth particle we have mn by an is equal and so on. And if we sum all these equations, so first equation is m1 by a1 is equal second equation is m2 by a2 is equal, ith equation is mi ai, and this is this equation, and finally nth equation, last point of the system, is mn by an is equal. Okay, and this is only one example of this system, and if we sum all these equations over I, so we get this. So we get sum of mi ai is equal sum of fi plus sum of fji. Okay, and we said previously that this is total external force acting to the system, and this is total internal force, what is 0. We said it previously, few minutes ago. So we get that sum of mi ai over I is equal external force. And this is main result of this talk. So sum of these multiplications mi by ai is equal to external force. And we can expand this idea and we can substitute this equation here and substitute for this, because we know that it is on the right side of this equation and here it is on the left side of the equation. So finally we get that m by ac is equal fe. Okay, and finally we get the law of motion of center of mass of a system of particles, where m is a total mass of the system. Total mass of the system of particles, and AC is acceleration of center of mass, and FE is a resulting external force acting to the system of particles. So this is result of our calculation. This is that law. So our conclusion is that for first, internal forces doesn't influence the motion of the center of mass of a system. And second, if the resulting force of external forces is zero, so if there is no resulting force acting from outside, resulting force of external forces, so the center of mass is in rest, so doesn't move, or makes a rectilinear motion with constant velocity. So it means if there is no external force, it means no resulting external force, so there is a system. So center of mass, this C, is keeps the position, so doesn't move, even if some particles make some motion, so center of mass doesn't change position. Or the center of mass is keeping, there is C, motion on line, straight line with constant velocity, if there is no external force. Okay, this is a condition.